Okay, so yes, let's do this question. It's a geometric progression and it's the application of it on a compound interest question. A compound interest question is a geometric progression. And the easier way is one way which they tell you that, okay, a certain company, remember interest means the money you get from making an investment. So it's you who's getting money, you're not paying anything. So interest, if they can even say you are charged 5% interest, that means that you are given. It doesn't mean that they are going to take from you. So anyway, it's the money which you get. So they can talk about a company, whatever, investing 100 puller or 1,000 puller at a compound interest of 8% per year, which we say per annum, right? Then they can ask you value after 7 years, whatever, what is the value? So when we are dealing with that interest, you see, you are investing, waiting for 7 years, then going to take it. It's going to be more. Right? In here, this is a slightly different, it's a different question. Similar, it's still talking about interest, but here it's saying calculate the value after something depreciates. So here we have it depreciating. So we can't really say it's an interest problem, but yes, it uses that similar thing because it's going to depreciate at some value per year, which is the same as gaining in interest. But in here, it is losing value. So when it's losing value, for interest, we write it this way when we have an interest problem. So here's our part A. When we have an interest problem and we want to find some value, okay? When we have an interest problem and we want to find some value, you can see the formulas of interest there a lot, okay? We can say that here, our value, new amount, we can say new amount is going to be equal to A, which is the first, then we say 1 plus the R, and it is to the power of n instead of to the power of n minus 1. Instead of just r to the power of n minus 1, it would be 1 plus r, and it is just to the power of n. And then here what you would say is, when we have this, okay, let's go ahead and let's apply in this situation. So if they say that you are gaining an interest of 8%, you just, because it's a percentage, that means it's going to be over 100. You get it to be, for a year for 0.5, it's 0.15, and you add it to the thing, to the 1, and you get it as 1.05 inside this bracket. That's what you do, okay? But now, in this case, it's depreciating, so it should be a negative value, which you bring. So it's going to be here, A multiplying 1 minus 0.15, and it's to the power of n, which is going to be A multiplying, here we start to use it. It'll be A multiplying 0.85, okay? So it'll be A by 0.85, and it is to the power of n. Here's how we'll get our amount. So it is, we call it the Tn rather. This is how we'll get the nth term, okay? Because we are looking for a certain term. They said calculate its value after 4 years, which is like the 4th term, right? So after 4 years, we'd say it's the 4th term. What would we say? It is going to be term number 4. It's going to be A 1 plus r to the power of n. And it's going to be equal to, here we saw that it is A times 0.5. It's A times 0.85 to the power of 4, okay? That is the term number 4. Wherever there is n, we're now putting the term number here. So it's going to be now, what is my A? We go up to see what the A is. The value that was invested, this 3,000, is your A. So we come here, okay? A. And then we have it as term number 4 is going to be equal to our A is 3,000 times 0.85 to the power of 4. So what do? We are going to say 0.85 to the power of 4. We get an answer, then we say times 3,000, and we'll get 1,566. Okay? So here we'll get our term number 4 being equal to 1,566 puller. So we'll have it as puller 1,566. This is going to be the value after 4 years. Okay, this is going to be the value after 4 years. Let's see what part B say. Part B says the machine is sold out when its value. Okay, so I'll do part B in the next one. Let's stop this one for here now. Bye.